bigger segments that we'll talk about here in the security space when technology breakdown is in the firewall category. So this is the one that everybody wants to talk about, right? When we talk about firewalls a lot, obviously we're out here in Santa Clara and we've got, you know, our good friends at Palo Alto Networks that we're working with on this. A firewall is what? Tell me what a firewall is. Just define it for me.
It's essentially a barrier that goes around the edge of your network that protects bad things from coming in and hopefully bad things from coming out of your network as well.
Yep.
Just like it's like having a fortress wall around your castle.
Exactly, and I love your softballs for me. So it's the perfect analogy, and we've used that analogy in IT for years. You know, we talk about castles and walls and moats and things like that. We build higher walls and they build bigger guns and, you know, things like that. So it's an analogy that we use frequently. And I like also that you mentioned it's at the edge of your network, so the border of your network, the perimeter of your network. You said edge, well, I'll kind of extrapolate off that. You're 100% right, and that's the part that really is horrible these days, because there is not really an edge to the network anymore, right? Because where's your edge? As I mentioned earlier in one of the other segments, back in the day, you had a corporate firewall, right? You went to the office, you used your computer at the office, it went out the corporate firewall, and that was it. You went home and you had your personal machine that went out, your personal cable modem, and I hope your personal firewall. If you didn't, call me, that's another conversation we'll have. But now, today, I'm the same way, you guys are the same way. I can work from anywhere. And as I mentioned other things, that's good and that's bad all at once. So where is that perimeter? So we'll talk a little bit about that. One of the big things about today's firewalls, they have gone into a much better job of traffic inspection, right? So legacy firewalls are, you'll hear me call old school or port and protocol firewalls. And without getting super technical on this, old firewalls, I mean old, like, 10 years ago, that's how old they are. Ancient. In today's world, that's ancient, right? We're more concerned about port and protocol. And at a basic level, we've all seen this, and you guys have some knowledge of it, right? So there's a whole bunch of ports on every IP address on the internet, right? There's 65,000 of them, to be candid, but anyway. We're primarily thinking, though, when you look like web traffic, or HTTP is the protocol, is port 80. That's a standard thing, right? SSL traffic is port 443. That's a pretty standard thing. Mail traffic is port 25. It's a pretty standard thing. The protocol is SMTP, and then we call it mail. Well, that's great. So in legacy environments, we would say, okay, I'm going to allow 25 in because I have to allow 25 in to talk mail, right? That's unsecured, but there's some things we can do there. And then we went to secured mail, and then I have to allow 80 in because I've got web servers. I have to allow SSL in because I got web servers. All right, so I got those three holes, right? But I have to allow those. Well, then I also have things that I allow out, right? And that's where it was a lot more interesting because we would just pretty much allow anything to go out. It's cool, you're on my internet, I trust you, you're on my network, go for it. Well, then we started getting a little smarter about that. We said, I'm not going to allow anybody to go out to the internet, and you're not going to use Telnet because Telnet was an open clear text protocol, not so much. I probably don't need to allow a secure shell outside my network. There's just not a good reason for that. So I'm not going to allow a secure shell to go outside. It's, usually you're using it for switch access, router access, shell access to things. Not saying it's a hacker tool, but I'm saying it's a hacker tool. I'm kidding. But there's not a good reason to really allow it outside my network from a firewall perspective, right? Or if I do, there's other things I can facilitate to do that, like VPN. So that was a pretty good start because then that made us fairly solid on the inside out. Well then, and I'll pick on Skype, the old regular commercial grade Skype, not the new business version, that really allowed that to change, right? So Skype was notorious for port hopping. So remember I talked about those 65,000 some ports? Well, the first 1,024 were reserved, right? I talked about mail, etc., and those are kind of locked, right? They're standard. Well, above 1,024, those are pretty much fair game. And I'm getting a little technical, but stay with me here. Skype would say, all right, I'm going to start at port 16,000. All right, cool. I don't like Skype. I'm going to block 16,000. Well, then the Skype developers got smart. That's cool. We'll just go to 16,001. Block that one. How about 16,002? You block that one. So pretty soon it becomes a game of whack-a-mole. So I'm either going to block all 65,535 ports. Fine, done. I'm going to do that. I'm going to allow these 4 ports to go out my network. That's cool. Guess what? We're just going to go ahead and allow Skype to go out port 80. Well, I mentioned earlier, right? What else was port 80? You remember?
Was it web server?
Exactly.
Yeah.
Good answer. So that's web traffic. Well, now I got a problem. I can't block port 80 traffic. I have to let it go out.
Right.
Well, that sucks. Well, about the same time, the bad guys get fairly smart. I'm going to start sending malware over port 443, which is encrypted traffic, right? And encrypted traffic is harder to diagnose unless I can do SSL decryption, which is another segment for another time. But so those two things combined with, now I got firewalls that are kind of dumb. They're kind of useless, right? I have no way to really see what's happening. So that's when we started getting into layer 7 inspection, or you'll hear it called App ID. Palo Alto Networks calls it App ID. You see it called application control, application visibility, deep packet inspection, whatever the word is. The firewalls now are application aware. So what happens now is that traffic moves through the firewall. Layer 7 aware firewalls can say, that's Skype. I don't care where it goes. I know by looking at that traffic, that pattern, the way it behaves and looks and smells and tastes and feels, that's Skype. That's web traffic. That's mail traffic. And I can even get as granular as say, that's Facebook basic, and that's Facebook games. I don't want that. We can actually get as granular to say, I'm going to allow the C-levels to use Skype, but only 10 megs. So you can't burn my pipe down because the CEO wants to chat with his granddaughter in Malaysia. We can lock that down. Maybe we give marketing access to like Twitter, Facebook, Instagram, things like that, because that's part of your guys' job. But I probably don't need my engineers banging around on Instagram, and Pinterest all day. If they are, we'll have that conversation. That's a different conversation. So we see a lot of that, and so we continue to see the firewall category improve. The latest thing we're seeing is a lot more east-west firewall traffic.
What does that mean?
Perfect. So east-west, north-south. What we do, I just drew across. I drew a compass across. Mm-hmm. That's great. When I talk north-south traditionally, that's usually a hardware firewall, or it's a firewall at the edge of your network. Usually we're talking corporate firewall. So in our scenario, think about traffic that leaves our corporate global data center out to the big bad interwebs, or traffic that comes in. We consider that north-south traffic, right? East-west is traffic that can move laterally or inside the network. So a good example is, it's just like your kids or just like your dogs. You go on vacation, and I know you travel over the world a lot. Let's say you go to Kuala Lumpur, yep, and you go to a Wi-Fi cafe with your corporate laptop, and you get something drive-by and your laptop gets owned. So now your laptop is this dirty, infected thing. You don't know it. And now, like any other bad kid, you come back to my network with your dirty, nasty laptop and you plug it into my network. Oh. And so now that traffic goes boom everywhere. So what we see now is the deployment of east-west firewalls. So we're actually segmenting certain internal bits. So we're going to give firewalls to accounting, firewalls to marketing, firewalls to IT, firewalls to critical machines. That way, even if you do bring back your nasty laptop, you might kill 10 of my machines at my office, not 18,500. Okay. We see a big deployment there with SDN, like with VMware NSX. Palo Alto Networks plays in there, Fortinet plays in there, OpenStack is doing more things around that. Cisco's in that space as well, some of the open source communities in that space. The virtualization has made it a big, easier thing to do.
Right.
Otherwise, you're not going to deploy 512 physical firewalls in all your data center locations, in all your offices. If you do, I want to be part of that project because that would be awesome. But generally, it's all with virtualization stuff. Right. So firewalls will continue to be a core critical piece of any security infrastructure. But what you're seeing is a lot more of the ecosystem where they have things that tie in, like a DLP, like a CASB, VPN that's controlled on it, some of the new next-gen antivirus that talks with those firewalls. So we're seeing that space.